Pneumatic actuators. Pneumatic actuators convert the air pressure into linear or rotary motion depending upon their design. Similar to hydraulic actuators, pneumatic cylinders are also used for gripping or moving of objects in various industrial applications. Pneumatic actuators, which are designed to produce linear motion, are termed linear air cylinders. Actuators, which are designed to produce rotary motion, are termed rotary cylinders or more popularly air motors. Linear cylinders. Classification of air cylinders. Linear pneumatic cylinders, popularly known as air cylinders, are used for the generation of straight rectilinear motion. Thus, they are useful to move an object or apply a force on an object in a straight line. Pneumatic cylinders are briefly classified as follows. Single acting cylinder. It is a cylinder in which air pressure is applied onto the piston side only and extension takes place by the air pressure in one direction. The return stroke is mostly by gravity. Spring return cylinder. It is a single acting cylinder in which movement in one direction is under air pressure while the return stroke is accomplished by a spring. Ram cylinder. In this, the cylinder rod itself forms the movable element termed as ram. It is usually single acting and return stroke is either under gravity or assisted by return cylinders. Single acting, spring centered, ram cylinder, double acting, double rod, rodless cylinder, diaphragm cylinder. Double acting cylinder. It is a cylinder in which the air pressure is applied alternately on either side. Double rod or through rod cylinder. In a double rod or through rod, the piston rod extends or retracts on either end of the cylinder. Rodless cylinder. In this, there is no rod connected to the piston. Usually, the piston is a magnetic type, while an external follower magnetic follows the piston due to magnetic coupling. Diaphragm cylinder. For short stroke lengths, small cylinders with a rubber or metal diaphragm is used instead of a piston. The main advantage of such cylinders is that there is no leakage between the inlet and outlet chambers and there is no frictional loss. Seals. Seals are used to avoid leakage and for smooth wear-free operation. Depending upon the type of construction, seals are used at different locations in a linear cylinder. Different types of seals: end caps, piston bearing, piston seal dynamic, end cap seal static, end cap, rod wiper, rod bearing, rod seal dynamic. Piston seals. Piston seals or piston rings are used between the piston and the barrel. These rings can either be metallic or non-metallic. Steel rings coated with zinc phosphate or manganese phosphate give a good life and operate smoothly. Non-metallic rings made of PTFE, polytetrafluoroethylene, widely known as Teflon, is chemically stable and tough. Because of its very low coefficient of friction, 0.04, it is ideal in pneumatic cylinders and can perform well without lubrication also. Piston cups. In some constructions, the piston is provided with piston cup seals. Compared to piston with rings, cup seals are much simpler in design and easy to assemble. They have an L section held on either side of a backing plate For a single acting cylinder, one cup is used on the pressure side, while for a double acting cylinder, two cups, one on either side, are used. The cups are held between the backing plate and retainer clamp. Leather or some synthetic materials are used for sealing cups. Rod seals. Rods are provided with three varieties of seals: a dynamic seal, synthetic material to prevent leakage of air, a rod bearing Teflon to support the rod in the end cap, and a rod wiper synthetic to prevent entry of atmospheric contaminants. In very dusty environments, rubber bellows are also used to protect the cylinder from the dust and other external particles. End cap seal, depending upon the design, either O-rings or die-cut gaskets are used to seal the end cap and the barrel. Synthetic rubbers and leather are commonly used for this purpose.